Charged particles in matter. In this module, you will learn about the charged particles in matter and their discovery. You might have observed that after rubbing a balloon against hair, it sticks to the wall. Can you guess why this happens? It happens due to the development of opposite charges on the balloon and the wall. These opposite charges attract each other. The charges on these two in turn develop due to the charged particles present in them. In fact, such charged particles are present in every matter. Now let us see where actually these charged particles are present inside matter. And what are these? We know that matter is made up of atoms. So, it is the atom which has these charged particles. When positively charged, these are known as protons. When negatively charged, these are known as electrons. Now that we know what these are, it is also important for us to know by whom they were discovered and how. The credit for the discovery of the electron goes to Sir J.J. Thomson. An experiment that helped him discover this was the cathode ray tube experiment. The setup of the experiment consisted of a glass tube containing a gas and two electrodes at its two ends connected to a battery. The gas inside the tube had a very low pressure, which was maintained with the help of a vacuum pump. On passing the electric discharge, the rays called cathode rays were produced, which were attracted towards the positively charged plate. As these were attracted towards the positively charged plate, these were supposed to be made up of the negatively charged particles, which were named by Sir J.J. Thomson as electrons. So this is how the negatively charged particles were discovered. Since atoms are neutral, it was concluded that some positively charged particles must also be present in the atoms. These positively charged particles were later discovered by Goldstein in 1886 as protons. The experiment set up for the discovery of protons was similar to the cathode ray tube experiment we saw before. The only difference was that Goldstein took perforated cathode in the middle and the fluorescent screen at the other end. On passing the electric discharge, the rays were observed which traveled in the direction just opposite to the cathode rays. These were named as canal rays and they passed from canal-like holes. As their direction was just opposite, it was concluded that these must be made up of some positively charged particles. These positively charged particles were nothing but the protons. So now we know all atoms have two types of charged particles, that are electrons, the negatively charged particles, and protons, the positively charged particles. Let us now compare some of the features of these particles. The charge of an individual electron is minus 1.602 into 10 raised to the power minus 19 coulomb, whereas it is plus 1.602 into 10 raised to the power minus 19 coulomb for protons. And if we compare masses, it is 9.107 into 10 raised to the power minus 28 gram for an electron and 1.672 into 10 raised to the power minus 24 gram for a proton. Moreover, an electron deflects towards the positive field and away from the negative field, and a proton deflects towards the negative field and away from the positive field. Now, let's recap. Every matter has charged particles. In matter, the charged particles are present in the constituent atoms. Each atom has two types of charged particles, electrons with the negative charge and protons with a positive charge. Electrons were discovered by Sir J.J. Thomson and protons were discovered by E. Goldstein.